Welcome back to the GT350 Garage. My name's Walter, and this video is going to be covering all of the block work and the block prep on the engine for my 66 Shelby GT350. Before we get started, I got a couple things I want to go over. One, it has been a while, and as you can see, I'm in a new garage. Moved this year, remodeled the old house. Massive undertaking. Getting this garage set up, equally massive undertaking. Organizing my stuff into an organized system, an equally massive undertaking. So a lot's been going on this year, and I'm really, really pleased with the way things have been going, but I haven't had time to do videos between remodeling houses and reconfiguring garages and organizing and my regular jobs. So anyways, I'm happy to be back. I'd also like to say thanks to everyone who's been hitting the subscribe button. The channel cracked 5,000 subscribers in October, and that's a huge milestone. I'm just really, really thankful for all of my viewers and everybody that comes and watches the videos. So anyways, thanks for watching. If you're new to the channel, subscribe, like, share the videos, and so let's get started. This is the block for my Shelby. It is a 1968 Mexican 302. The block itself is basically a service replacement for a 289 hypo block. It has the hypo style main caps. Other than that, a Mexican 302 block is essentially the same as a 289 hypo block. There's rumors on the internet that and before the internet, that they had high nickel content, that they had thicker main webs, that there was more material in the block, that the material wasn't as high a quality as a Windsor or Cleveland foundry block. All of that is kind of a moot point. The nickel content's been disproven. The quality of the cast iron's been disproven. These are good blocks, but they're essentially the same as a 289 hypo block. The only block that you're going to find with these big, thick, heavy main caps on them that have any additional material in them are the B50 Sportsman blocks that Ford Racing sold in the very late 90s, early 2000s, and those things are getting hard to come by. They're out there. They are hydraulic roller. They have the heavy-duty main caps. They do have a little more material in the main webs, but there's some limitations on how much material you can put into the main web on a small block Ford to begin with. So for all intents and purposes, this is what we're working with. It's dead equivalent to a 289 hypo block for my purposes, and we're in good shape. Now, this is the block that the machine shop that was supposed to just wash the block board 60 over, and it had to be sleeved. And because it had to be sleeved, it had to be line honed. So this block has been line honed, and because it was line honed with factory style bolts in it, the only options I had were to run factory style bolt or to run ARP bolts and then leave it alone. Now I'm going to run a windage tray. So if you look closely, the number 2 and number 4 main caps have Boss 302 main bolts in them. That's the reason I'm not running ARP hardware, and it's nothing against ARP. They just don't make a bolt suitable for bolting a windage tray to. The other alternative to this bolt would be the factory stud type bolt that you find on the number 3 main cap on a 5-liter block. You would need 4 of those bolts so that you could set the main cap or the windage tray down onto the main caps and use locking nuts to be able to hold it down. In this case, I'm going to use bolts, and I'll put a drop of blue Loctite on them just because. But other than that, we're good. Now, why didn't I put studs in it? There's a reason. if you put studs in, it changes the way you load the fastener against the cap, and it changes the distortion on the cap, meaning you can end up with a main bearing that's not quite round, because I don't want to mess with the roundness, especially on a block that's been line honed already. I'm running bolts. So these are things that are considerations that need to be taken into account. Let's roll this thing over and let's talk about, there we go. Let's talk about the cylinders. So the cylinders were unintentionally bored 60 over, and then they had to be bored even further and sleeved. So there's a sleeve in every one of these cylinders. And after it was sleeved, it was finished to a 30 over bore size, so 4.03, and power honed and then plateau honed to finish the cylinders. Now, what is plateau honing? Maybe you guys can see this board, but a normal hone mark has ridges. And you want to catch the oil in the bottom of these grooves, and your piston is going to slide up and down on this, right? So these sharp points that are left by the honing stones, what's going to happen is they're going to take your ring facings off. So when you hear about guys having to seat the rings, it's generally because the honing job ripped the facing off the rings, and now you're trying to seat a cast iron ring. So the trick with a plateau hone is it takes the peaks off, and it leaves you with flats. And the flats become this wonderfully smooth surface that the ring can glide on, but it leaves the valleys so the oil is still there to lubricate and seal the rings. So if you're not doing this when you're building your engine, I highly recommend it on any future engine build you might want to do. The brushes come from Goodson. They're under $100 in most cases. They have them in different bore sizes, and the bore size ranges, if you're doing small block Fords, you're going to need one that'll do anything from a 4 to 4.25 bore, and you're good. One brush will do any cylinder size in that range. They're very versatile, relatively inexpensive. You can either run them with a drill and finish the cylinder that way, or you can actually chuck them up in a power hone and you can stroke the brush in the bore just like a honing stone. I've had guys tell me, oh yeah, I plateau hone, I do it with a stone. If you plateau hone with a stone, you're going to end up with peaks. I don't care how fine the stone is. So keep that in mind, and it's just something that improves the ring seal from the minute you start the engine, and ultimately provides a better ring sealing surface for greater longevity on the engine. This is something that factory engine blocks are done this way and have been for almost 40 years. So if it's good enough for the factory, it's good enough for me. I want that nice smooth finish. I want that good ring seal. I want that longevity. So another thing that we did, anytime you install sleeves, you're going to have to deck the block to cut it, to level everything out. But we went a little bit further on this one, and this block has been decked to 8.190 inches. That is the blueprint spec. Now, why is 8.190 the number? Well, let's say this was a 302. It's going to be a 289, but it all adds up the same. Okay, so your throw on a 302 is 1.500. That's the throw, half the stroke. Your rod is 5.090. And then your piston is 1.600. 8190. 289, 302, they both come out to 8190. Okay. By taking the deck down to 8190, we put the piston flush with the deck. With the piston flush with the deck, our quench area is now determined by our head gasket. So the distance from the piston to the head, which is our quench area, is the thickness of our head gasket. On a steel rod engine that's seeing 7,500 RPM, 40 thousandths is perfectly adequate. I know guys that will run them tighter than that. The less RPM you run, the tighter the clearance. The more RPM you run, the longer the rod's going to get when you're at full boogie. You start getting up to 8,500, 8,800 RPM, you need 42, 44 thousandths so that you don't kiss the piston to the face of the head. And that's just one of those things that, if you're new to engine building, that's something that you wouldn't necessarily consider. Decking the block. The stock block is going to be 8.206 to 8.211. So that means we're cutting between 16 and 21 thousandths off of the deck of the block. That's going to move the heads down. Now I've also milled the heads for this engine 66 thousandths. So my intake ports as a result are down at this point from that a total of 87 thousandths. So I will have to cut the intake manifold to get perfect alignment. Not a big deal. Okay. And basically you cut the intake manifold faces 2/3 of whatever you deck the block and the heads. So totally doable, very fixable, easy problem to solve. So that's some of the machining stuff that's happened with the block. I was particularly upset about the block being bored 60 over. They could not find another standard bore block to fix their mistake, so they fixed it by sleeving it. I did manage to find another standard bore block, a standard bore Mexican 302 that can go 20 over is about $600 these days for a reasonably clean casting. That'll take 20 over, 20 or 30 over. If you want one that's standard, that you can still run standard, be prepared to pay $800 to $1,200. And in a world where hypo blocks are now $4,000 to $6,000 for usable hypo blocks, you can understand why I'd sleeve a block. My machinist that I use regularly, he's sleeved all 8 holes on blocks before, and we've run the living daylights out of them. So it's not a big deal. It's going to run hot. It's going to fail. When they fail, it's because somebody didn't do the job right. And if they ran hot, it's because the engine's not tuned right or somebody didn't do the job right. So just keep that in context. These sleeves didn't even go into the water jackets. Okay. So that's where we're at with this. But anyways, next thing, let's roll this thing over a little bit more. So if you look in here, you can see that I've drilled 2 holes and tapped them. This is the only thing I didn't film that I did personally. This is so that I can run a spider and the stock dog bones for hydraulic roller lifters. And it's really important that if the cam bearings are already installed, do not drill this hole over 3/8 of an inch deep, 0.375. That's as far as you want to go. Get a caliper out, wrap some tape around your drill bit, stop when your drill bit hits the edge of the tape. It will be more than enough, 3/8 of an inch. If you use a 3/8 fastener, you're only going to go 1/4 of an inch in because, well, you'll you'll go 3/8 of an inch in on this one that's got a boss back here, but in the one in the front, to make the spider level, you got to put a washer the same thickness as this boss underneath it. That basically simulates the stock factory mounting anyways, and at that point the bolt's only 1/4 of an inch in, so you're not going to bottom the bolt and you don't have to worry about it coming loose. Because they are small bolts, again, you're going to put blue Loctite on them when you assemble it. Blue Loctite, not red. Red is permanent, requires heat to remove. Blue is semi-permanent. It's designed to hold the fastener, but it's not going to damage the threads. So little stuff there, and that's to set this thing up so I can put a hydraulic roller cam in it. Now, this is going to be a very high-performance 289, but I'm not calling it a 289 hypo because I don't want to make the purists unhappy. Okay, because if it was going to be a 289 hypo, it'd have to have iron hypo heads, it'd have to have a hypo block, it'd have to have a hypo crank and hypo rods and a mechanical cam. So let's not go there. If you guys want to be particular about that stuff, this isn't the channel for you. Anyways, so the final thing that I did film and I'm going to show you is something that we need to address, and you can see it again here. We have a steam hole at the 12 o'clock position on an early block. Now, early blocks are considered by most to be a little bit better block. This is where this steam hole is kind of important to understand why it's here. There's a change in the shape of the casting inside the valley. There's actually a higher rise over the cylinder so that coolant can flow through here into the cylinder head, steam can flow into the cylinder head. On a 5-liter block, there's not as much material on this side of the cylinder, and as a result, the steam hole's moved over here. Well, in order to use a late model style cylinder head, we either have to have an eyebrow cut in the head to transfer steam, which means it's got to go up and then travel down and then get back into the cylinder head, or we had to add holes here. And this block, I drilled it, and you'll see that in the video. So with that, that's where we're at as far as stuff that I've had to do to this block. Ultimately, this engine should make at least 100 horsepower per liter like a modern GT350. So we're 293 cubic inches. That's 4.8 liters. I'm 100% positive I'll make at least 480 horsepower. We'll see what it makes once it's in the car. We'll put it on a dyno and get some results. But until that point, right now, anything I say is just basically it's a very educated guess. And I don't want to put an exact number on it because, well, again, somebody's going to be, oh, I told you you weren't going to do that, or I told you your number was wrong. I don't care. Like 480 horsepower out of a 289 is no joke. Okay, 480 horsepower out of any small block is no joke. And you put 480 horsepower in a car that weighs 2,800 pounds, it's enough to get after. So we're going to have fun. I'm going to enjoy this. Now let's get started on the block prep. All right, let's start at the top left and work our way around. I'm going to go over the components that we're going to use for this block prep. Here's our rear cam plug. Here's our rear oil plugs for the back of the block. This is going to plug our lifter and main galleys. This is our block plug for the upper rail. This is where our oil crosses over from bank to bank at the rear of the engine to feed the lifter galleys. Here's the front lifter galley plugs, and then you'll see I have a whole bunch of freeze plugs here. These are sorted. This is 3 sets of freeze plugs. These are brand new freeze plugs from Pioneer, as are all of these. These are some old plugs I had laying around, and these are some plugs that also I had laying around, but these do not say Made in USA. These do. These do. If we look at these plugs, the tallest of the 3 are these ones in the front. The reason I never used these middle ones is they are really deformed when they were stamped. So I keep them around as a discussion piece, not because I'm going to use them. These are the deepest of the ones that I have, and these plugs are nicely formed. They don't have any weird distortions or anything like that. So these are the plugs that are going to go in the engine. Moving over, this is a flat tappet block that I'm converting to hydraulic roller. So we have the spider, we have the dog bones, and we have the bolts to hold it down. These are pretty short compared to a standard 5-liter bolt. A standard 5-liter bolt is actually a 1/2 inch bolt like the thrust plate on the front of the engine. These are 3/8. So they're pretty short. And the reason for that is if you drill the hole any deeper, you get into the cam bearing, and that's bad juju. So we don't want to get into the cam bearing, and we're going to be really careful when we tap these, just so that we can be sure that they're going to work. And then these will go in with Loctite. Now, this is the thrust plate for the Ford Racing B302 camshaft timing set. This is a steel upper gear, not a cast gear, and as a result, it requires a steel thrust plate. A lot of people don't read the catalog footnote and use the wrong thrust plate with these. This is a necessity. Ford no longer includes the thrust plate in the timing set like they used to. Used to be you'd order a timing set, it came with dowel pin, thrust plate, everything you needed. Now it's just chain and 2 sprockets. These are new OEM replacement timing cover bolts. Little word of caution here. If you're using a late production or a reproduction early timing chain cover, you're going to need 4 long bolts and 2 short bolts, not the other way around. So I have 2 more long bolts that I'll be using. And the short bolts go in the top, and then the long bolts will go in the bottom. These are replacement main bolts, and you'll notice these are Boss 302 style main bolts and Boss 302 style windage tray bolts. This is because I'm adding a windage tray to the engine, and ARP does not sell a bolt like this. I have never really had any issues at all with stock style bolts on a 302. I don't stud them. I don't girdle them. At the power levels I run, I've never had an issue, so I stick with what works. And then this little pile of stuff over here. You'll see that we have this little screw, and that is for a bolt-on timing pointer. We're not using a bolt-on timing pointer. This is a Woodruff key for a longer slot than a 289 crank has. These are the dowels that you would use if we had a 5-liter block and timing cover. Because we're running a early block, these dowels do not get used. All right, when we start our block prep, we're going to start at the back. This block's been cleaned. It's ready to go. So I use Ultra Gray. I don't use pipe sealer or Teflon tape on these. The Ultra Gray is nice, consistent, always works. It's never failed me. So to apply the Ultra Gray, I put the plug on and I just give it a little spin. And I'm looking for an even, consistent coat. And I'm going to thread this in. I'm going to go until it's snug. And then I'm going to give it a quarter. And then a half a turn. And that's plenty tight enough. It does not need to be super tight in there. It's a pipe plug, and it is a tapered fit. So once it's in, it's in. And that's pretty tight. You don't need to put a torque wrench on it or do anything crazy. So just repeat that for the rest of your plugs. Just a little coat. Try not to drop it. Thread it in. That's half. There you go. Nice and tight. If you're concerned that you have a little too much on the inside, just wipe it off. Okay, there we go. There's a quarter, half. Oh, that's good and tight. If you want it any tighter than this and you're using an Allen key and not a ratchet, go ahead and put a wrench on your Allen key. Works like a charm. Okay, here's a mistake a lot of guys make. They will put silicone on this plug, and that gives the plug a means to pop back out. This plug is designed to go in dry. It does not need to have any sealant on it. This is not a straight edge, it's a taper. So the further you press it in, the tighter it gets until the back edge is all the way in. This hole has a small chamfer on it, and we're just going to set this plug in nice and straight. And then you need a socket or something that you can drive it in with that is the size of the plug. And then you're going to need a hammer. This is a 4-pound hammer. Keep your plug straight. And the plug is in. That's it. You're done. All right. Once you have your oil plugs in the back and your cam plug in, you can put your engine adapter on. So let's line this guy up. And we want to start the bolts by hand. And then I like my engine adapter kind of above the crankshaft, not below it, because we're going to have more weight up here than we are back here. Once it's on, tighten it down. And that's adequate. It's not going anywhere. All right, this is the part that a lot of guys get the engine crane out, and this is a good reason to work out, stay in shape, so that you can do this kind of stuff. You're gonna just pick this guy up. and put it on the stand. All right, this is going to be a little controversial. Some of you guys are going to say, no, 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 you have to use sealer. But you don't have to use sealer if these bores are clean. And what I've done is I've run a tool in here. I have an arbor that lets me put Scotch-Brite pads in it. And I've cleaned these with a Scotch-Brite pad. So they are clean and they're smooth. Now I have a freeze plug installer. And these are just going to tap in. Just like so. And you can see I got this one a little deep. It's a little deeper than I like it. I generally try and go just to the point where this ridge, there's just a ridge here. You can catch your fingernail on it. Okay. So this one's a little deep, and the fix for that, knock it all the way in. Grab it with a pair of pliers, pull it out, and once it's been used, you can see that it's been crushed. So if I put this plug back in, it will leak. And I have one spare deep plug. So there we go. Done. All right, it's time to put the front plugs in. Now, if you look carefully, I'm going to zoom in. If you look carefully, you can see where the previous builder staked these plugs. Okay, we're going to put in 3 plugs. We're going to utilize this drift that fits nicely inside. Line it up. Okay, so one of the last things we're going to do is we're going to stake the plugs. For that, you're just going to need a straight chisel. And to stake the plugs, just tap 3 places. And the hard one to do is this inner one. And you can cheat. You can go through the distributor hole. Okay, we need to plug our rear crossover. And if you're going to restrict oil, this is where you'll do it. The only time you would restrict oil is if you're running mechanical lifters and you want to limit oil to the valve train. This being a priority main oiling system, we want oil in the valve train, so I generally don't restrict the engines. This is a hydraulic roller application, so we need the oil for the lifters to operate properly. We're not going to restrict it. Find yourself a socket that the plug fits kind of close, but not snug. If it fits snug, it'll get stuck because the taper is going to close the plug up as you press it in. So it needs to have a little bit of play and it should spin freely. Put your plug in. This is just an old socket. And this is one where you can tap it in until it stops and you're good. It's flush, or it's flush with the hole. It's under the sealing surface for the intake manifold, so we're good. Okay, so this has been staked before. You can see there's a mark here, and there was a mark there. So we don't want to stake in the exact same place. 1, 2, 3. And that plug will not go anywhere. That and the intake manifold's above it, so it's not coming out. Okay, so you can kind of see there's a little black mark here that's been center punched on each cylinder, and we have 4 of them. These are the steam holes to match a late model style cylinder head. Most of your aftermarket aluminum cylinder heads are going to require you to drill these holes, so that's what we're going to do next, is drill those holes. Okay, so at this point, we're going to set the head dowels just loosely into the block. These are trick flow head dowels, not OE style. I have the OE styles if I want them. Doesn't matter which way you put the head gasket on to check this, because the gasket has the holes in both positions so that it can be installed left or right. But put this on and we're close enough. We have functional steam holes. So this portion of the block prep is done. You saw that I masked everything off and I used magnets to collect the filings, and that's just a silly precautionary thing that I chose to do. Okay, so block prep's done. Couple things I want to mention, and this belongs at the end of the video. I hope you've stuck around this long because this is important. At this point, this block needs to be washed one more time. So hot, soapy water and a good detergent, a good grease-fighting detergent. I like Dawn. Most dish soaps will work, but Dawn's not particularly expensive. So I'll go buy some Dawn, and I keep a bottle of it in the garage. It's in one of my bins. And put some dish soap in about 4.5 gallons of the hottest water you can get. And I recommend a 5-gallon bucket and the bathtub. That's the best way to get the hot water. Get the thing out in the sunlight, wash it, and don't be afraid to go at it basically with like a car wash sponge type deal. You can brush the engine down, do whatever you want to do, clean it up, pour the soapy water through the engine, roll it over, pour it through. Go get 5 more gallons of hot, clean water, no more soap. Rinse with the hottest water you can possibly rinse with. The reason for the hot water is it'll evaporate better, and it just makes drying the block easier. It warms the block up a little bit, so the block naturally wants to dry. If you're working with a cold block, and let's face it, it's cast iron, so if it's not the warmest to begin with, the hot water will help warm it up, and that will aid in the drying process. So hot water for cleaning, use dish soap and get it clean. Once it's dry, and for the drying process, I cannot stress enough, you need to use compressed air. If you don't have compressed air, you're kind of asking for it. Use compressed air. You need to blow out all the holes. So every bolt hole, every lifter bore, every oil galley, blow everything out. Roll the engine around multiple times. Blow air into the coolant passages with the block upside down. That will help push any water, any moisture that's in the block out of the block. Get the block as dry as possible, and then hose it down with WD-40. WD-40, the WD stands for water disbursement. A lot of people don't realize that. The WD-40 will push any remaining water out of the surface of the iron. It'll push it out of anywhere it might be hiding. Once you've sprayed it down with WD-40, blow it off again, and then wipe it down with a clean, lint-free rag. Okay? And at that point, the block itself is ready to go. You can start working on other steps of the engine building process. Now, speaking of the engine building process, the next step is going to be putting in main bearings, measuring our main bearing journal or main bearing diameters. We're going to measure the crankshaft. We're going to put the rod bearings into the connecting rods. We'll measure all of the rod bearings with the rods torqued. And once all of these measurements are taken on the crankshaft and on the bearings, I will go through and fine-tune the clearances on the rod journals by picking which rods I'm going to put on which journal. Then I'll assemble the pistons onto the rods. And if you're using a press-fit piston, you don't really have that option all that much if the pistons are sized to the individual bores. Again, that comes down to who's your machinist. My machinist, he actually sizes the pistons to the bores. So I'll check the rods. I'll figure out which rod's going where. My pistons are numbered to which cylinder they belong with. Every cylinder has been sized to every piston. And so the clearance is exactly the same. So anyways, at that point, I'll measure everything, I'll line everything up. That's going to be the next video. Until then, I want to thank everybody for watching. And again, I want to thank everybody for the subscribes. 5,000 subscribers is kind of surreal. I really appreciate all of you guys. So for now, stay safe out there, and I'll see you in the next video.